Okay, I want to talk about projectile motion with an angled launch. And what I mean is a launch that is done with a velocity oriented at a particular angle. We'll usually measure that angle from the eastern horizon. So let's say, for example, that the velocity is 10 meters per second at an angle of 30 degrees, just to make this nice and simple. And we can use vector components to break it down. So there actually is a vertical and a horizontal component to that velocity vector, a v sub x and a v sub y. And you find out that v sub x is equal to the vector 10 meters per second times the cosine of the angle, cosine of 30 degrees. V sub y is then equal to the vector 10 meters per second times the sine of 30 degrees. You can put this into your calculator. And I don't really probably need a calculator for this, because this should equal 8.7, approximately 8.67 meters per second. And this here is going to equal 5 meters per second. So those are your initial launch conditions. So let's think about this. Vertically, we know it travels a distance y. It does it with an initial velocity, a final velocity, an acceleration, and a time. Horizontally, it travels a distance x. It's got an initial and final velocities, an acceleration, and a time. And we know the acceleration here is 0, and we know the acceleration here is negative 9.8 meters per second squared. So what does this tell us? It tells us if that horizontal velocity, that velocity in the x direction, is 8.7 meters a second, then their final velocity's got to be 8.7 meters per second. And you can solve any horizontal problems with a simple constant speed equation. Distance is velocity times time. That's it, right? How far, like, let's say you know that it lands, well, I need to be careful how I phrase these questions. Let's say that it hits a wall after, I don't know, travels, say, like 20 meters. How long does it take? Well, you know that it's gone 20 meters, and it's doing it at a constant speed, so VI, you end up getting distance is velocity times time. It's gone 20 meters when it hits the wall 8.7 meters per second times time, so your time is going to equal 20 divided by 8.7, which is 2.3 seconds. So often these questions can be solved by breaking it down into its two components and figuring out which one do I need to actually solve this problem. On very rare occasions you might need to deal with both, but oftentimes just solving it with one of them is enough. Let's look at the vertical motion now. So vertically, we know that it is going at 5 meters per second. And that's it, right? So think about this. Like, the other parameters can be set based on where it's going and what's happening. So this is the path, for example. At the top, VF is going to equal 0 vertically. So if you wanted to solve for what happens at the top, you could just say, hey, I know what VF is. VF is equal to 0. And now you have 3 variables, and with kinematics equations, you need 3 variables, and then you can solve for the other 2. The only exception is something like this, where you have 3 variables, but 2 of them are the same. You need either position or time in order to solve for it. If you don't want to do that, you could say, hey, what happens at the bottom? At the bottom, we can say, well, you return to your original elevation. That's one thing that we can say. And in fact, another thing that we can say, and I'm not going to, you can work this out yourselves, but your V final should be exactly the opposite of your V initial. So if it went up at 5 meters per second, its speed should be negative 5 meters per second. So you could say, hey, Vf at the bottom, when it hits, Vf is negative 5 meters per second, and your elevation is 0. And again, you can put these into kinematics equations and solve them, and we'll practice a little bit of this in class. There might be other things. It depends on what parameters you're given. Like they might say at a height of 10 meters, and then you say, hey, y is 10. One thing to keep in mind, if you're not sure how to do it, if you find the time here, it takes as long, the same amount of time to go this distance as it does to go this distance. So if you find one time, you find the other time as well. And you just add them up for the total time. I hope this helps explain things. We'll do a little bit more practice. One thing that you can do eventually is if you can solve one of these sides, you can say, hey, when it hits, I put my variables in, I found time when it hits, and I want to figure out how far it went horizontally, I can say, hey, I know the time, and I put it in here, and then you can solve this for time using distance and velocity times time. But make sure, please, 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 horizontally is always constant speed with an acceleration of 0. Vertically is always acceleration downward at negative 9.8. Thank you very much for watching.